everyone. So today we're going to do an introduction to trigonometry. It's going to be the first lesson of our trig unit, which happens to be one of my favorite units, even though I say that about all units. So we're going to start with the do now. The do now is some kind of review type questions. The first one says simplify the following radical. So just a reminder, to simplify radicals, you have to find the biggest perfect square that goes into the number that's underneath the radical. So 98. If you try to find the numbers that go into 98, you'll see that the biggest perfect square is 49. And this becomes radical 49 times radical 2. Okay, now when we simplify this further, the 49 becomes a 7, and the radical 2 stays a radical 2. Just going to move this up, and that becomes our final answer. Now, the next part is something called rationalizing. So it says, rationalize the following fraction. This means to get the radical out of the denominator. To do that, you have to multiply the numerator and the denominator by that same radical. Okay? So we're going to start by multiplying this by radical 98 on the numerator and the denominator. When you do this, square root of 98 times the square root of 98, that just becomes regular 98. The radical goes away. And this is over 3 times radical 98. Now, as we did in part A, radical 98 simplifies to 7 radical 2. So this becomes 3 times 7 radical 2 over 98. We can multiply 3 times 7. That gives us 21 radical 2 over 98. Now what we should do is try to see if we can simplify the two numbers. So this 21 over 98. So we're going to open up our calculator. Again, if you don't have the calculator apps, for the iPhone it is Calculate 84, and for the Android it's Wabbity Moo, if that's even how you say it. So to see how this simplifies, what you would type into your calculator is the fraction. So we have 21 over 98. So we go alpha, y equals 21 over 98. Press enter, and it does simplify to 3 over 14. So that's what we're going to write here. We're going to write 3, radical 2 stays there, over 14. So that answer would be a rationalized answer. Okay, so what we're doing today is an intro of trigonometry. Now, trigonometry is all about triangles, okay? Trigonometry, triangles. It helps us find distances and it helps us find angles. We are using right triangle trigonometry, which is where we use the good old saying SOHCAHTOA, which is what a lot of you remember from geometry, or you at least heard of it before. So kind of a little review of SOHCAHTOA. This is just something to help us with the trig ratios. So sine of theta. Now you're always going to have sine, cosine, or tangent of an angle. So they'll give you an angle to look at. In this example, that is theta. So sine of theta is equal to the opposite side, which is opposite the triangle, over the hypotenuse. The hypotenuse is always the longest slanted side. It is also the side across from the right angle. So this, opposite over hypotenuse. Okay? Cosine. Cosine is the adjacent side. Adjacent means next to. So here's our angle. This is the side that's next to our angle. So this is equal to adjacent over h, which is again our hypotenuse. Or for short, a over h. And lastly, we have tangent. Tangent is equal to the opposite over the adjacent. Which is O over A. So that's where SOHCAHTOA comes from, and we are going to use that. Now, we also are going to be dealing with reciprocal trig functions. So our first reciprocal trig function is called cosecant. Now, cosecant is the reciprocal of sine. So the cosecant is 1 over sine of our angle. Okay? Now, if sine is opposite over hypotenuse, the cosecant is the flip of that. So it's hypotenuse over opposite. Next reciprocal function is called secant. Secant is the reciprocal of cosine. So secant is equal to 1 over cosine. Or if cosine is adjacent over hypotenuse, you just kind of flip that. So the cosecant ratio is hypotenuse over adjacent. Now the last one is cotangent. Cotangent is the reciprocal of tangent. It's kind of in the name there, so that's the easiest one to remember. So cotangent is 1 over tangent of theta, and if tangent is opposite over adjacent, cotangent is adjacent over opposite. So again, it's just kind of flipped. Now, we do have a bunch of vocabulary to get through, so if you need to pause the video at any point, please do. So, quadrants. Quadrants are the 4 areas made when you have an x-axis and a y-axis. It's important that you know which quadrant is labeled which. So you start at this quadrant right over here. This is quadrant 1, where both the x and the y are positive. So this is quadrant 1, then you go counterclockwise to count the rest. So then you go to quadrant 2, quadrant 3, quadrant 4. It's very important that you know this is counterclockwise. We are going to be dealing with angles since this is trigonometry, so you need to know these important angles. When you start at the first quadrant, you're at 0 degrees. At this right over here, this angle here makes a 90-degree angle, so that degree is 90 degrees. If you look over here, it's a straight line from 0 to here, which is 180 degrees. Then we have 270 and 360. So for each quadrant, you are adding 90 degrees. Okay, some more vocabulary. Standard position is when the vertex of an angle is on the origin. So that means this right here is the vertex of your angle. So then it splits off from that point. The initial side is where the angle starts. So it always is going to start on the x-axis, so on that 0 degrees. And the terminal side is where it ends. That could be wherever on your graph. Some more vocabulary is reference angle. We're going to be finding the reference angle today as well. So reference angle is the smallest angle the terminal side of the angle makes with the x-axis. So it's different for wherever your angle is. Now, if you're in quadrant 1, the reference angle is the angle that you have. It's going to be the smallest angle because it starts here and ends here, okay? So that would be our reference angle. Now, let's say we had an angle in quadrant 2, okay? You have 2 options for your angle. You can either look at where this angle is, so from the x-axis to the end of your angle, or you can look from your angle to the x-axis. Now, the red line is smaller than the black line. which tells us that this red line is our reference angle. And the same applies for all of these. So if we look at this example, this black line shows the angle in standard position. But if we go from the x-axis to where this angle is, the red line is obviously smaller than the black one. Same thing here. This black line goes almost all the way around, which is our standard angle. But this small red portion here, that is our reference angle. Okay, so very important, this is how you find your reference angle. First things first, you need to know where the angle is, okay? That's why it's so important to know that this is 0, 90, 180, 270, 360, because that'll help you place where the reference angle is. Now, to find the reference angle, there are 4 rules, okay? Now, I highly suggest copying this down somewhere because this is very important. Or if you like the table better, you can copy the table. So if you're in quadrant 1, the reference angle is your angle. If you're in quadrant 2, to find the reference angle, you do 180 minus whatever your angle is. If you're in quadrant 3, you take your angle and subtract 180. And if you're in quadrant 4, you do 360 minus whatever your angle is. So if you need to pause the video, pause it to copy that down. It's very important. Okay. Number 1, it says, find the reference angle for a rotation of 200 degrees. So first thing we have to do is find out where this angle is. So I'm going to sketch it. Okay? So here was 0, this was 90, this was 180, this was 270, and it came back here to 360. Now, 200 degrees is somewhere here. Okay, it's somewhere between 180 and 270. Now, if you look at our rule, it's in quadrant 3. Okay, so to find our reference angle, we have to do theta minus 180. Theta was 200, so we have to do 200 minus 180. 200 minus 180 is 20. So that right there is our reference angle. Moving on to number 2, it says find the reference angle for a rotation of 120 degrees. So again, first things first, let's figure out where this is. So this is 0, 90, 180, 270, 360. Our angle is 120 degrees, so it's somewhere over here. It's between 90 and 180. So that is in quadrant 2. So we have to use that rule. So we do 180 minus theta. Theta represents your angle. Now we do 180 minus 120. 180 minus 120 is 60 degrees. So that is our reference angle. Alright, and here is another example. Find the reference angle for a rotation of 285 degrees. So always start off with your sketch, just so you know where to look. Okay? To find an angle of rotation of, find the reference angle for a rotation of 285 degrees. 285 is somewhere here. Okay? So this is the 4th quadrant, because remember, it goes 1, then we go counterclockwise. So it is the 4th quadrant. So our rule for that was 360 minus theta. Our theta is 285. Then we would do 360 minus 285, and we would get 75. So our reference angle here is 75 degrees. Okay? All right, so the last thing we're going to do is we're going to practice the trig ratios. So this says find all 6 trig ratios for A. So we are looking at angle A, so we are looking right over here. If it helps you, you can label the sides. So if this is A, opposite of A is right here. So this is our opposite side. Adjacent of A is right here. So this is our adjacent side. Now this long slanted side here, which is across from the right angle, is our hypotenuse. So if it helps you to label it, you can label it. You don't have to though. So we're going to start with the normal sine, cosine, tangent. So we have sine of A, cosine of A, and tangent of A. Okay? We remember what the ratios look like from SOHCAHTOA. So also if you need to write that down, write it down. Okay? So sine is equal to opposite over hypotenuse. The opposite was 7. The hypotenuse was 25. You should always see if you can simplify it at all. If you have trouble looking at it and simplifying it that way, go to your calculator, alpha, y equals 7 over 25. And it stays the same, so that means you can't simplify it. So sine of A is good. Now cosine. Cosine is adjacent over hypotenuse. The adjacent side was 24. The hypotenuse was 25. Again, if you want to check if you can simplify it, go for it. And tangent is opposite over adjacent. So opposite is 7. Adjacent is 24. And that's sine, cosine, tangent. Now the other 3 ratios come from the reciprocal ones. So the reciprocal of sine A was cosecant of A, of cosine was secant, and the reciprocal of tangent is cotangent. Now to find those ratios, you're just flipping that fraction. So instead of 7 over 25, 25 over 7. Instead of 24 over 25, you flip it, 25 over 24. Same thing here, you flip it. So 24 over 7. Okay? And that's going to be it. If you would like to practice, which I highly suggest you do, please take time to work on these problems. Alright, to get credit for today's class, you must complete this problem and post a picture of your work and your solution onto the assignment posted on Google Classroom.